We're going to do absolute value equations today in this video, and then absolute value inequalities I'll cover in another video. So the first thing that you want to know is just a review of what absolute value is. It's the distance from zero on a number line. So it doesn't matter what direction you're heading. If it's 4 steps, it's 4. So this absolute value of -4 would be 4 because it's 4 steps. Absolute value of 4 would also be 4. This is important to understand because when I put x in the absolute value and I tell you it equals 4, you no longer know anymore that x is exactly this. You know that it could be -4. You know that it could be 4, but you don't know which one. So it's important to understand that when we're doing absolute value equations, they're always going to have two solutions. The first type of absolute value problem is the one where the variable is all by itself in the absolute value. These ones are usually the easiest. You do the same thing always with every absolute value problem. You always look to see if there's any numbers outside of it, and you get rid of them first. And you get rid of them by solving the equation like you always would. Think of this absolute value as the variable that you're isolating. So I subtract 2 on both sides. I have the absolute value of x equals 7. Now at this point, I have to decide, is this 7 or -7? And the answer is that it's both. So you can say x equals -7 and 7. I sometimes like to write it like this right here, write both numbers underneath. And then if it's asking you to graph it, because you don't have one of these type symbols, an inequality symbol, you just plot the 2 points. So if I went 0, 2, 4, 6, 8, I would just have a solution on -7 and 7, and there would be no arrows in between, no arrows pointing in any direction, because this is what makes the arrows. They're just equal. Let's take a look at the next one here. So again, I'm just going to look at this variable right here, or this absolute value as the variable I'm trying to isolate. So I will subtract 5 on both sides, and I'll get the absolute value of n equals -7. Now this is an important problem right here. This one equals no solution. We've had a couple different types of no solution problems. It's anytime so far we've come across any time where they're not really equal to each other or the statement that you end with isn't really true. What makes this one a no solution is that you're trying to tell me that, or it's trying to tell me that an absolute value is negative. And if you look up here, if the number inside is negative, the absolute value is positive. If the number inside is positive, the absolute value is positive. It is an absolute distance. So a distance really can't be negative. Even if a person was walking backwards, they'd still be going a distance. So the fact that you have an absolute value trying to be negative is what makes this a no solution. The number inside can be negative all at once. The solution can be negative. An isolated absolute value cannot equal a negative number, though. All right, let's take a look at the next type of problem you're going to see. These ones are a little more complex in some ways, and that's because when you're trying to isolate this absolute value, there's stuff in it. There's an expression, we call that. So if there were any numbers outside of it, I would try and add or subtract or divide or whatever to get rid of those outside numbers first. Here's the next step. I have to assume that what's inside of here resulted in 8, so it might have equaled -8 in there for real, or it might have for real equaled 8. I don't know which. Like -4 was 4 and 4 was both 4. I don't know whether this expression equals -8 or 8. So I have to solve both of them. So I say 3x minus 1 equals -8. And I have to say 3x minus 1 equals 8. Take note of the fact that I had to drop the absolute values when I did this because I'm trying to say it's negative. I also have to drop the absolute values because I'm trying to find out what's just in that absolute value, of course. So I'm going to add 1 to both sides. I'm going to get 3x equals -7. I'm going to divide by 3. And I'm going to get x equals, and you can say negative, 7/3 if you want. And you can say -2 1/3. Now again, this number couldn't be negative. If this is alone, there's nothing outside of it. But the number that you get in here, that can be negative any time. I'm going to add 1, and I'm going to get 3x equals 9, and I'll divide by 3, and I'll get x equals 3. So my two solutions are x is negative 2/3, and x is 3. Either one of those two numbers, if I plug them in, would make me multiply by 3, subtract 1, and equal 8 in the end. Now here's a problem that you want to look at that actually you do have to do some isolating first. So when you look at this, you have your absolute value. That's the thing you want to isolate before the problem splits. I'm going to have to get rid of this 4 first though. Do not ever distribute. Don't look at that 4 and think it can distribute in like these are parentheses. They act like parentheses sometimes, but not here. So I'm going to divide by 4. Notice how that line goes all the way across, not just under the 4. And I'm going to divide by 4 here. I'm going to get the absolute value of v minus 5 equals 1. Stop always at this step and check. Is your absolute value trying to be negative? If it is, it's a no solution. This one is not. So I'm going to split this problem into 2. And I'm going to say v minus 5 equals negative 1. V minus 5 equals 1. Notice when I do this that this part of it doesn't change. They're both v minus 5. What's changing is this part. The 1 shows as a 1 and a negative 1. I'm solving for the fact that this might have been either one on, it might have been either 1 or negative 1. I add 5, I get v equals 4. I add 5, and I get v equals 6. And those are my two solutions. And I could check it if I want, so I could take that 6 and put it up here and say, is it true that 6 minus 5, which is 1, 4 times the absolute value of 1 really does equal 4? You can check that math and just see if it works. If we give this one a try, again, I have an absolute value that I need to get isolated first. If you look, your absolute value is sitting here. You need to get rid of that minus 5 first. So you come in and do a plus 5 here and here. And you have the absolute value of 3x minus 6 equals negative 2. Whenever you're at this stage, absolute value is isolated. Take a second, give it a look, just make sure your solution to that isolated absolute value isn't negative, because it can't be. Absolute value is a distance from 0. If it is, write no solution under it. Take a look at our next one here. There's nothing outside of this absolute value that needs to be added or divided to get rid of, so I immediately split this problem into 2. Now drawing those arrows is a choice. I just always do it. You don't have to. You can just start by writing 2x plus 3 equals negative 4 and 2x plus 3 equals 4. Now remember, you're dropping the absolute values, so that negative is now cool. That's okay to have, because the absolute values get dropped at this stage. I'm going to subtract 3 and get 2x equals negative 7. I'm going to divide by 2 and get x equals negative 3.5, negative 3.5, negative 7 over 2, whatever makes you happy. I'm going to subtract 3. 2x equals 1. And x equals 0.5 or 1/2, whatever makes you happy with that. And there are your two solutions. Now, as you work on your homework today or your practice sheet today, come back to the video if you need to and watch a couple problems being solved. Remember, this is new to you. You have not done this before. So that means you might need to watch it a couple of times. You might need to give it a second look. A lot of times when we're learning new things, they don't just immediately take root in our head. We have to practice and check and practice and check. All right, talk to you guys later.